We have electromagnetism to thank for a lot of different things, from like allowing you to watch YouTube videos on a computer that is powered by electricity and holding all of the atoms in the universe together. But electromagnetism, as the name implies, takes two forms that look totally different to us. We have the electrostatic force and the magnetic force. But don't be fooled, electricity and magnetism are the same freaking thing. Weird, I know, but since this is my show and I can do what I want, I'm gonna break this up into two episodes, one on electrostatics and one on magnetism. First, electrostatics, the cause of lightning and balloons sticking to me. As you probably know, electromagnetic force acts on objects that have electric charge. In electrostatics, they're described as either being positive or negative. Objects with opposite charges produce an attractive force between them, while objects with the same charge produce a repulsive force. The greater the charges, the greater the force. And the greater the distance between the charged objects, the smaller the force. All this was laid out nice and simple by French physicist Charles-Augustin de Coulomb in what we now today call Coulomb's law. Coulomb's law is able to describe how protons in an atomic nucleus, which are positive, keep negatively charged electrons from just wandering off. And just like with other fundamental forces of physics, there's a special particle that conveys this force. Here, you've actually heard of the particle. It's called a photon. Photons carry the electrostatic force between the electron and the proton. Photons are the same particle that carry light and heat, which is why electromagnetic force is able to travel at the speed of light. Now, electrostatic force is called static because it can build up in an object, creating a ton of potential energy that's just dying to move someplace. Take this balloon, for example, and my wool sweater. They are both made up of atoms, as you might imagine, and atoms normally have the same number of electrons and protons, so they're electrically neutral. But some substances tend to take on electrons really easily, like rubber, while others tend to give them up, like wool. When substances with these opposite tendencies come in contact, the electron from the atoms of one substance jump into the atoms of the other. So when I rub the balloon on my sweater, the balloon gains electrons, becoming negatively charged, and my sweater loses electrons, making it positive. Now, it might look like the friction of me rubbing this is causing the charge, but that's not true. Rubbing is just putting the atoms into contact over and over again, making it more likely that they'll swap electrons. The more they swap, the more charge gathers in one place, and the two oppositely charged objects cling together. They're effectively just sharing electrons when they touch. The same thing is going on with lightning. Electrostatic force builds up in rain clouds as they rub together. Once enough electrons are built up in the clouds, they need to go someplace that has a bunch of protons to neutralize them. So the atoms in the air basically serve as a path to deliver these built-up electrons through the sky from their negatively charged source, the clouds, to their positively charged destination, whether it's the ground, another cloud, or some really unlucky person. So electricity is just a stream of electrons trying to get from a negative place to a positive place. And isn't that what we're all trying to do, really? The crazy thing is that once electrons start flowing like this, it creates a magnetic field. And what? But that is why next time we're going to be talking about the magnetism portion of electromagnetism. Thank you for watching this episode of SciShow. If you have any questions or ideas, you can leave them for us on Facebook or Twitter, or of course in the YouTube comments below. And if you want to continue becoming smarter with us, go to youtube.com/SciShow and subscribe.